The repeating decimal that we're going to use today is 0.48 or 48 hundredths. Now this is repeating. So basically what this means is 0.48, since the line is over the 4 and the 8, that means that the 4 and the 8, those are the numbers that are repeating. Like that. So since 4 and 8 are repeating, there's no need for us to write 48, 48, 48, 48, dot, 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 because we know that because the line is over those two that they're going to keep going. We're going to let this repeating decimal 0.48 be equal to x. So basically we're going to say x is equal to 0.48. I'll add another one, 48. And of course, we know that that repeats. And the next thing we're going to do, we're going to form an equivalent equation. And we're going to do that by multiplying each side of this equation by 10 to the n, with n being the number of repeating decimals. So in this example, the 4 and the 8 both repeat. In other words, since there are two numbers repeating, the variable n will be equal to 2. So 10 to the n is equal to 10 to the second power, which is equal to 100. So now what we're going to do is we are going to multiply both sides of this equation by 10 to the 2, or 100. So on the left side equation, we're going to multiply times 100. And on the right side of the equation, we're going to multiply times 100. And the resulting equation is going to be 100x is equal to, now when you're multiplying by numbers, you basically move the decimal point 2 places in this case because we have 10 to the 2. So since it's 10 to the 2 power, we're going to move 2 places. So 100x is going to be equal to 48.48. And we're going to do another one repeating. So now we have x is equal to 0.4848, which is right there. And then the other one we have 100x is equal to 48.48 repeating. Now the next thing we do, we're going to subtract x from 100x, and the value x here is 0.4848 right there. So we're going to subtract x from 100x. So from this 100x, I'm going to say minus x. X is equal to 0.4848. So we're going to subtract 0.4848 from 48.4848. And as you can see, even though these two are repeating, these are going to cancel each other out. So now we're left with 100x minus x, which is 99x, is equal to 48. All we simply do at this point is solve for x. So since this x is connected to this 99 by multiplication, we will have to do the inverse operation of multiplication, which is division. So we're going to divide by 99 to isolate that x on the left side of the equation. And whatever you do on one side of the equation, you must do to the other side of the equation. So now, once we simplify this equation, we're left with x is equal to 48 over 99. Now, we're not done yet. And the reason we're not done yet is because if you look at 48 over 99, that fraction can be simplified. This fraction, as I said, needs to be simplified. So in order to simplify this fraction, we need to find the GCF of the numerator and the denominator. We need to find the GCF. In order to find the greatest common factor of 48 and 99, we need to make a prime factorization tree of both of the numerator and denominator. And when we list the prime factors, 48, the prime factor of 48, as you can see, the common factor we have here is 3. So the greatest common factor of 48 and 99 is now we found the greatest common factor of 48 and 99. We take that greatest common factor of 3 and divide it into the numerator and into the denominator. 48 divided by 3 is 16, and 99 divided by 3 is 33. So, .48 repeating converted to a fraction is equal to 16 over 33.